Hey, good morning, Algebra 2. This is 1.4, multiplying and dividing rational expressions. So this is going to be really similar, pretty much exactly the same as what we did when we were simplifying. The only difference now is there's a multiplication sign between them, but we're going to ignore that and we're just going to make this one whole part. Okay, so we're going to simplify this out. So 2 times x to the 4th times y to the 5th. 15 can become 3 times 5. Okay, and then we have an x squared. Okay, down here we have a 3 times x squared. 8 can become 2 times 4. And then x to the 3rd y squared. So now I'm just going to combine my x's and y's, and I'm going to go ahead and cancel my numbers that I can cancel. Alright, so now I'm going to have 5. And up here I have x to the 4th times x squared, which is going to be x to the 6th. Y to the 5th over, down here I have a 4, I have x squared and x to the 3rd, so that's going to be an x to the 5th. Remember, when you're multiplying you add. Okay, y squared. And now I'm going to go on ahead and do the division. Okay, so 5 over 4 is going to stay the same. But remember that when I'm dividing with exponents, I'm subtracting. So I'm doing the top exponent minus the bottom exponent. So it would be x to the 6th minus 5 equals x to the 1st. And then y to the 5th minus 2 is y to the 3rd. Okay. And in this case, anytime you have x's and y's multiplied in the denominator without having any binomials, it's just going to be x, or polynomials, x cannot equal 0 and y cannot equal 0. Okay. Alright, so let's take a look at this next one. Okay, so for this next one, I'm going to go on ahead and I have my x plus 2. I have x plus 2. Okay, but now I need to factor this. So I can pull a 3 out and I'm left with x plus 4. Okay, and x squared minus 4 is difference of squares, so that's going to be x minus 2 times x plus 2. Okay, so now I'm going to cancel everything I can. And that's all I could cancel in this case. And so now I'm going to be left with x plus 2 over 3 times x plus 4 times x minus 2. And, I don't know why I put an equals there. X cannot equal, so now I have to set all of these things equal to 0 to find out what my x cannot be. So 3 equals 0, that never happens. X plus 4 equals 0, subtract 4 from both sides, and I get negative 4. X minus 2 equals 0, so add 2 to both sides, and I get 2, and then x plus 2 equals 0. Subtract 2 from both sides, and I get negative 2. Okay, so that's my whole answer. You need to make sure that you include this, and this is going to become really important here shortly, because we are going to be doing asymptotes, and you're going to have to really understand how to solve these things. Okay, so let's go on ahead and do the next one. Okay, so I'm going to do the same thing. I'm going to do my 3. Okay. I'm going to go on ahead and do my 10 right next to my 3, okay, just so my numbers are close together. And then I'm going to go on ahead and combine my x to the 5th and x to the 3rd. X to the 8th, y to the 3rd times y to the 4th is y to the 7th. So this one I wrote out a little bit more. This one I'm combining a little bit more. So now this is going to be a 2. And 9 is 3 times 3. X to the 3rd times x squared is x to the 5th. And y to the 7th plus y to the 5th is y to the 12th. Okay. So now that's going to be a 3, a 3, a 2, a 2. Okay. So now I'm going to be left with 5 over 3. Alright, so let's cancel. So there's 8 of them up here and 5 of them down here. Okay. So if I cancel these 5, there's 3 left up there, and that's doing the same thing. I'm just kind of talking you through it a different way. Okay, and this is going to be the same thing. So if we did y to the 7th minus 12, we'd get y to the negative 5. But remember, we never keep negative exponents, so that really means that there's going to be y to the 5th in the denominator. The other way to look at it is if I can't cancel 7 of them here and cancel 7 of them here, I have 5 left down here. Okay, and remember that x can never equal 0 and y can never equal 0, or whatever. If there's a z down there, it can never equal 0. Okay, if they're just multiplied together. Okay. Alright, let's go on ahead and take a look at the next one. We have x minus 3. We have x plus 5. That goes to the top one. Okay, 4 4x plus 20, we can take out a 4 and we're left with x plus 5. And x squared minus 9 is difference of squares, so that's going to be x minus 3 and x plus 3. And now we're going to cancel, so that cancels and that cancels. Okay, this is the part where you have to remember and you have to be careful. Okay, because remember that when we do this, we're really dividing. We're dividing a number by itself and it gives us 1. We're dividing a number by itself and it gives us 1. So really 1 in the numerator, and that's x times x plus 3 in the denominator. Keep writing equals. Okay, so now x cannot equal, I have to set all of these equal to 0, and I get negative 5, positive 3, and negative 3. Okay. Alright, so we're going to look at dividing as well. Dividing is the exact thing as multiplying. Okay. The only difference is, remember, we never divide by a fraction. We always multiply by the reciprocal. So I had a fraction here, 3 halves divided by, 4 sevenths. I would not divide by 4 sevenths. I would multiply by 7 over 4. Okay? So we're doing the same thing here. So we're actually taking this second one and we're flipping it. Okay? So it's really going to be 4x to the third over 9x squared y times, flip this, 9y to the fifth goes on top, and the 16 goes on the bottom. Now remember that when you do this, you only flip the second one. Okay? Alright, so now we're going to go on ahead and do it just like we did the ones above. Okay? So I'm going to cancel this just a little bit different so you guys can see. Okay, so up here, when I did the multiplication, I was actually rewriting them out as 2 times, 4 or whatever. Up here, I'm going to do, what I'm used to doing with fractions. So 4 and 16, 4 becomes a 1 and 16 becomes a 4 because they're both divisible by 4, and 9 is both divisible by 9. Okay, so they cancel. Okay, so really, I'm left with 1 over 4 here. Okay, x to the third and x squared leaves me with an x. And y to the fifth and y leaves me with a y to the fourth. And remember, there's no polynomials down here, so x cannot equal 0 and y cannot equal 0, okay, because those are the two variables in the denominator. Okay, so that's just another way of doing it, okay, a little bit easier. And this one, we're going to get into a little bit more difficult now. We're dividing, so we need to flip that. So first thing I'm going to do here is I'm going to go on ahead and I'm going to factor all of these, and then I'll rewrite it flipped. Okay, so x to the fifth minus 4x to the third, I can pull out an x to the third, and I'm left with x squared minus 4. Okay, but that x squared minus 4 becomes x plus 2 and x minus 2. Alright, so that's my first piece, x to the third, x plus 2, x minus 2. And then I'm going to factor the x squared minus x minus 2. So it multiplies to negative 2 and adds to negative 1 is going to be x minus 2 and x plus 1. Okay, same thing here, except remember this one has to go on the top because I'm flipping this. Okay, so that's going to be an x minus 1 times an x plus 1. Okay, and here I can pull out an x to the third. Okay, so if I pull out an x to the third, I'm left with x squared minus x minus 2. And that's going to leave me with an x minus 2 and an x plus 1. Okay, so now I'm going to go on ahead and cancel things. Okay, but the biggest mistake I see on these is forgetting to flip that second one, or you flip both of them. Okay, remember, you only flip the second one. X minus 2, x minus 2. Alright, so it looks like we're going to be left with x to the third times x plus 2 times x minus 1 over, oh, look at that, our x to the thirds cancel too. See, so we're not even left with that. Okay, and then we're going to be left with x plus 1 in the denominator. Just making sure nothing else cancels here. Yep, so we're going to be left with x plus 1 times x minus 2 in the denominator. Okay. Alright, so now we have to say what x cannot equal. And remember, we have to do this entire one right there. Okay, so we're going to use the multiplication one, not the division one. Okay. So we're going to say x cannot equal 0 because x to the third equals 0 is 0. Okay. Positive 2, so that's twice, and negative 1, and that's twice. So we don't have to write it twice, we just have to write it once. All right, going ahead and try the next one, and then we'll do it together. And hopefully you tried it, so if not, pause it right now and try it. Okay, so now I'm going to flip this second one. I'm going to be left with 5x to the 4th times 8y to the 5th over 8x squared y squared times 15. So now I can start canceling things out. So 8 and 8 cancels, 15 and 5, that becomes a 3. Okay, so now I'm going to be left with x to the 4th minus x squared is x squared. Y to the 5th minus y squared is y to the 3rd. And I'm left with a 3 in the denominator. Okay, in this one, there's no polynomials. The terms are x and y, the variables. So x cannot equal 0 and y cannot equal 0. Okay, going ahead and pause it again and try this next one. Okay, and now hopefully you have tried it. So let's go on ahead and factor these out. So 2x squared minus 7x minus 4, that's going to give us a negative 8x squared. Okay, so that's going to give us, let's see what multiplies to negative 8, negative 8 and 1, which adds to negative 7. So that's going to be 2x squared minus 8x plus 1x minus 4. And do my factor by grouping, and if you have a different method, of course, with factoring, once again, I don't care, just make sure you know how. So now I can pull out a 2x here, and I'm left with x minus 4, and here I have to pull something out, so I'm going to pull a 1 out, and x minus 4. So my answer then is 2x plus 1 times x minus 4. Okay. X squared minus 9 is a difference of squares, so that's going to be x minus 3. Times x plus 3, 4x squared minus 1, that's a difference of squares, but remember, I have to flip these, so that 4x squared minus 1 is going to break up to 2x minus 1, and 2x plus 1, and now this last one, 8x squared minus 28x plus 12, I can pull a 4 out of this, and I'm left with 2x squared minus 7x plus 3. Okay, so now I can multiply, and I'm going to get 6x squared, and that's going to become 2x squared minus 1x minus 6x, and then plus 3. I do my factor by grouping, and I'm left with x, 2x minus 1, and here I can pull out a 3, a negative 3, and I'm left with 2x minus 1. Okay. It's going to be x minus 3 and 2x minus 1. But don't forget that 4 that we pulled out in the beginning. Alright, so now let's start canceling things. So 2x plus 1, 2x minus 1, x minus 3, and we're left with x minus 4 over x plus 3. But remember, we have to set all of these equal to 0 and solve. So x cannot equal 3, negative 3. Okay. If I set this 2x minus 1 equal to 0, I'm going to add to both sides first. And I get 2x equals 1, and then I'm going to divide by 2. Okay. And I get x equals 1/2. And the same with the other one, but I'll get negative 1/2. Okay, so as you start doing these more and more, you'll get really good at this. And I'm just double checking it. I forgot my 4 up there. Okay. Alright, so division. Okay. Not too terrible. Okay. Same as multiplying. Multiplying is the same as simplifying. Okay. You just have to learn the steps. Okay, so let's go on ahead and let's go to these complex fractions. Complex fractions are the same exact thing as division. Okay. So it's a fraction divided by a fraction. So really what I'm going to do is I'm going to multiply by the reciprocal. So now I'm just going to go on ahead, and here there's nothing I have to factor. Okay, I can't cancel anything, so my answer is x plus 2 times x plus 5 over x minus 1 times x minus 3. And my x's cannot equal, and remember I use my denominators when I'm multiplying, so x cannot equal 1 or 3. Okay, so see, that was exactly the same as division, okay, because that's what it really is. So same thing here, this is division. Okay, so I'm going to multiply by x over x minus 1. And we came back to this one when we did this originally because I talked to you guys about adding first because these are fractions. So I have 3 over x plus x over 2. Okay, so these are fractions with uncommon denominators. Okay, so here, in order to get a common denominator, I have to multiply this by 2 and I have to multiply this by x. And whatever I do to the denominator, I have to do to the numerator. So really, I'm going to get 6 plus x squared all over 2x times, now I'm going to do that x times x minus 1. Okay, so really it's the same exact thing. Okay. So now let's see what can cancel here. This x can cancel with that x. I can't factor anything. There's nothing else that I can do. Remember that I can't cancel this 2 and this 6 because the 6 is really part of this binomial. Okay, so I'm just going to rewrite this x squared plus 6. I can do that, right? I can rearrange their order. Okay, over 2 times x minus 1. Okay, and x cannot equal, so now I'm going to use those pieces, 0 and 1. And the last thing that we're going to do is solving rational equations. Well, the last thing for 1.4. Okay, so for 1.4, solving rational equations, we need to get rid of this denominator. So in order to get rid of this, we're going to multiply x plus 3 on both sides. Okay, so now we're going to have x squared minus 9 equals 7 times x plus 3. Well, this right here becomes x plus 3 times x minus 3. Okay. And this becomes 7 times x plus 3. Okay, now I went on ahead and I multiplied first, and really, you can, okay, but if you look at this, I can get rid of some stuff here, right? So, in order to solve rational expressions, remember I need to get everything to one side. Okay, so now, if I go on ahead and divide by that x plus 3 again, okay, then those are going to cancel. Okay, so here, if I had done it first, if I had done x plus 3 times x minus 3, then those would cancel automatically. Okay, so now I'm left with x minus 3 equals 7, add 3 to both sides, and I get x equals 10. And I can plug it back in and check. Okay, now the one thing I need to be careful of is I know that x cannot equal negative 3. Okay. So I need to check these to make sure that it fits. Okay. So let's go on ahead and take a look at this next one. So the first thing I'm going to do here is factor, okay, unlike I did here. Okay, so I'm going to factor here. So what multiplies to negative 4 and adds to positive 3 is going to be 4e and negative 1. Okay. So now that's going to cancel. Okay, so now I'm left with just x plus 4 equals 5. Subtract 4 from both sides and x equals 1. Okay. Now, let's go on ahead and plug this 1 in here. Okay, so if I plug 1 in, okay, I'm going to get a 0 in the denominator there. Okay, so I have to be really careful when I'm doing this and make sure that it's a value that can be used. Okay, so this one right here, the value x equals 1, it says cannot actually be used.